So our first discussion for today is work. What is work? The work done by a force is defined as the product of the force and displacement in the direction of the force. So ang formula sa work ay work equals force times displacement, then ang atong unit kay joule. So, first example, Beatrice applied a force of 13 Newton to push a cart on the frictionless floor to a distance of 8.6 meter. How much work is done? So dara ang given. Ang force na to kay 13 Newton nga naman kay if na ang unit kay Newton, automatic mao nang force kay ang unit sa force kay Newton. So ang distance na to kay 8.06 meters. So i-solve, i-add, i-multiply na nimo. So 13 times 8.06 meters equals work equals 104.78. So atong unit di kita kalimtan, unit na to mo na atong unit joule. Unit sa work kay joule. So ibutang ta na da joule. So mao na yung final answer. Proceed ta sa ikaduhang nga example. So Roldan used a horizontal force of 15 Newton to push a cart on a ramp which is 8.2 meters long at an angle of 35 degree above the horizontal. What work is done? So ang kalayan na ni sa naguna nga example kay nani siya theta. So ang gamito na tong formula ni kay work equals force times distance times cosine theta. So add ato na ning i-multiply. 15 times 8.2 times cosine 35. So 100.76 yung atong unit kay joule. Di ginakalimtan. Wah!
So our next topic is all about energy. So what is energy? I'm sure kitang tanan familiar na unsa ang energy. So by definition, energy is all about the ability to do work or the capability to do work. Now there are different types of energy as we are all familiar, pero sa kani is ang ato ang i-focus on two broad topics or ang categorize two broad topics of energy, which is ang potential energy and kinetic energy. And later on ato siyang i-discuss and we will give examples para ma-identify unsaon siya pag-solve. So ang first energy nga ato ang hisgutan is all about potential energy. So what is potential energy? Para sa yun nga definition or sa yun nga mailhan, potential energy is the stored energy or energy at rest. So pasabot mo na siyang energy ang gigipossess sa usa ka butang nga wala naglihok. So basically, for example, na usa ka tawo nagbarog ra siya, so ang gipossess na nga energy is potential energy. Now, we provided two different forms of potential energy, namely the gravitational energy and the elastic energy. So first, atong discussion is all about gravitational potential energy. So what is gravitational potential energy? Para simpler definition, it is the force nga ang gi-oppose is ang gravity. So ang iyang focus is the gravitational field. We have here the first example of gravitational energy. Number 1, a 20 kilogram suitcase is raised 3.0 meters above the ground. What is its potential energy? So this is the formula for the gravitational potential energy. M stands for mass, G stands for gravity, and H stands for height. So ato na siyang isolve, followed by the formula. So that is M. Ang ato ang M is 20 kilograms multiplied by the gravity, which is 9.81 meters per second squared, multiplied by the height, which is 3.0 meters. So, imo ra na siyang i-multiply. Then, ang atuang potential energy for this one is 588.6 joules. So, don't forget na ang unit sa energy is joules. We have another example for gravitational potential energy, which is number 2. What is the gravitational potential energy of a 2.5 kilogram book that is 10 meters above the ground? So, diri sa number 2, same ra atong gamiton nga formula, which is ang formula sa gravitational potential energy, mass times gravity times height. So, ato na dring i-distribute 2.5 ang iyahang mass times the gravity 9.81 meter per second squared times the height, which is 10 meters. And then the answer for that one would be 245.25 joules. Now, you have to remember nga if ang pangutana gani is na I word nga or phrase nga above the ground, then pasabot ana ang gipangita is gravitational potential energy. So the next form of potential energy after sa gravitational potential energy is the elastic potential energy. So what is elastic potential energy? Ang inyong dapat dali ra mahinumduman about elastic is that it talks about spring. So since elastic potential energy is also called spring potential energy, mora na inyong dapat hinumduman in case naaray mga suwat nga compressed or stretched or anything nga involves a spring, then that energy possess elastic potential energy. So we have an example of elastic potential energy. Number 1, a spring with a constant of 2.6 newtons per meter is stretched a distance of 0.7 meters. What is the potential energy in the system? So since this is all about elastic potential energy, mo ni ang dapat hinumduman sa formula sa elastic potential energy. PE equals 1/2 kx squared, in which ang k stands for spring constant and with the unit newtons per meter, while the x stands for the distance and ang ihang unit is meters. So ato na siyang isolve using this formula of elastic potential energy. PE equals 1/2 kx squared equals 1/2 ang iyong spring constant 2.6 times the distance 0.7 and ay kalimot ang squared sa babaw. So with that, ato na siyang i-calculate and the answer is 0.637 joules. Don't forget nga ang unit sa energy is always joules. So number 2 example for elastic potential energy. A truck suspension spring each have spring constants of 769 newtons per meter. If the potential energy of the front right spring is 250 joules, how far is the spring compressed? So sa kaning number 2 nato nga example, as you can see na siya difference sa number 1. Ang gipakita nga given is the spring constant, its elastic potential energy, and ang atong gipangita is the distance. Now how to do that? Ang inyong gamiton nga formula is same lang gihapon sa potential, sa elastic potential energy. We have 1/2, and since given na ang PE atong isuwat diri ang 250 joules, distribute and then write the 1/2. Given na ang spring constant which is 769 and then ang gipangita is ang distance. Now ikahuman ana imong i-multiply ang 1/2 769 and ang answer ana is 384.5 and then copy ang x squared. Ikahuman imo na siyang i-over ang 250 over ni mag 384.5 same as diri sa pikas para ma-cancel siya para mahabilin ang x squared. So cancel, mahabilin na ang x squared and diri is 650.195. Now this is not the final answer since kinahanglan mawa ni diri ang squared. So ang buhaton na imo na siyang i-square root. Square root na nimo kana mahimo na lang ng x and then ang square root ani nga value remember dili pa ni siya hilabtan diri, dili ni round up kay dili pa man ni ang final answer. So ikaw mag square root ana, our final answer will be 0.81 meters, so 2 decimal point, then that is your distance. So, sa next type na sad nato nga energy after sa potential energy in which na forms nga katong the gravitational and the elastic. Next nga atong topic is the kinetic energy. So what is kinetic energy? I'm sure familiar na tatanan what is kinetic energy, but into further knowledge pa, kinetic energy into simpler definition, it is all about the energy in motion. So basically, energy basta ang kana ganing butang is naglihok siya. For example, na ay tao nga naglihok. So basically in motion man siya, then ang gipossess ana nga energy ana is kinetic energy. Now in kinetic energy, we also provided two different forms. So under kinetic energy, we have translational kinetic energy and rotational kinetic energy. So later on, atong masabtan unsay kalahian sa duwa, and at the same time, what are the formulas nga gamito nato in order para makuha nato ang kinetic energy ana nga butang. So first nato nga type or form sa kinetic energy is the translational kinetic energy. So what is translational kinetic energy? It is the energy of an object moving along a straight path. Very understandable. So now we have an example of translational kinetic energy. So here it is, number 1. What is the kinetic energy of a 5 kilogram block sliding across a frictionless horizontal surface at 12 meters per second? So again, it is all about translational kinetic energy. To find translational kinetic energy, you have to use this formula. Kinetic energy equals 1/2 times mass times velocity squared. So mass, unit niya kilogram, while velocity unit niya is meter per second. Now ato na siyang isolve using this formula. So that will be 1/2 mv squared. Just okay, atong kalimutan suwat. And then 1/2, ang mass niya is 5. Ang iyahang velocity is 12 meters per second, so subutan 12. And then 1/2 and 12, ito siyang square, that is 144. And then 1/2, 5 times 144, that is 720. And then 1/2 times 720, then that is 360 joules. So that is our kinetic energy or translational kinetic energy for number 1. So we have the second example. A cart that weighs 15 kilograms is rolling down a hill with a velocity of 4.2 meters per second. What is the kinetic energy of the cart? So, sa number 2 nato nga problem, same ra ang gatong gamiton sa number 1 using this formula, still ang gihapon. Now, number 2 is very tricky siya, kaya na siya word nga rolling down. But still, use this formula. So, ato siyang i-distribute ang mga given. 1/2, our mass is 15 kilograms. Ang atuhang velocity is 4.2 meters per second. Now, ayaw kalimot sa squared. Then that will be 15. 4.2 atong square, that is 17.64. And then 1/2, 15 times 17.64 equals 264.6. Now, kanina sa imo i-multiply, then that will be the kinetic energy or the translational kinetic energy for this one is 132.3. Ay kalimot sa unit, which is ang joules. So the next form of kinetic energy nga atong i-discuss is the rotational kinetic energy. So what is rotational kinetic energy? It is the energy of a rotating object. So very understandable na kaayo ang kani nga kind sa kinetic energy. Now to further understand this type or this form of kinetic energy, which is the rotational kinetic energy, we will provide an example. So first, a 5 kilogram disc with a radius of 1.3 meters is spinning at an angular speed of 15 radians per second. What is the inertia of the solid disc and what is the rotational energy of the disc? So kani nga first example, as you can see, first we have to discuss unsa man ang formula sa rotational kinetic energy. So this is the formula: 1/2 times the inertia times the angular velocity squared. So ang kaning inertia, ang unit aning inertia is kilogram meters squared, while ang kaning angular velocity is radians per second. Now, as you can see diri, walay given nga inertia, pero naay given nga angular velocity. So atong buhaton na pangitaon sa nato ang inertia. So ang formula to get the inertia is 1/2 times mass times radius squared. So atong ibutang copy 1/2 and then ang mass na to is 5 and then we have the radius of 1.3 ang kalimot sa squared. So ato na siyang i-multiply. I know, i-jutso na lang nato siya calculate. So the inertia for this one is 4.225 kilograms meter squared. So we have now the inertia. So makuha na nato ang rotational kinetic energy using this formula, which is 1/2 times the inertia times the angular velocity squared. So we're gonna do this. Distribute the value. Inertia na to is 4.225 kilograms meter squared times ang atong angular velocity, which is 15 radians per second. And then, after that, ato na siyang idritso na lang nato ni siya calculate. And then, that would be 475.31 joules. And don't forget, diba, basin nakalimot ko. Makalimot mo, kaya nakalimot kong butang og square dire. So, that's it. So, para mas makasabot pa ta, na ako i-provide na sa another example sa rotational kinetic energy. So, number 2 example. A round grindstone with a moment of inertia 1,600 kilograms meter squared is rotating at an angular velocity of 6 radians per second. What is grindstone's rotational kinetic energy? So, sa number 2, ang atong gamiton na ni is same lang gihapon nga formula, of course, kaya ang gipangita man is rotational. So, mo ni ang rotational sa rotational. As you can see, given na ang inertia, unlike sa problem 1, so mo ni atong inertia, moment of inertia, and then given na sad ang angular velocity, which is on 6 radians per second. So, all you have to do is to distribute the givens. Ang atong inertia is 1,600. Ang ang angular velocity is 6. Now, don't forget again, ang squared sa babaw. So, ato na siyang tagsatag sa una lang para masabtan. Ang 6, atong squared, 36. Now, 1/2, multiply ang duha. Then, that is 57,600. Now, i-multiply na sa ni para makuha na to ang kinetic or ang rotational kinetic energy. That is 28,800. Don't forget the units energy. It's always joules.
Next topic is work energy theorem. The net work done by external forces on a body is equal to the change in kinetic energy of the body. It states that the net work done by external forces on a body is equal to the change in kinetic energy of that body. The work energy theorem is a powerful tool that can be used to solve a wide variety of motion problems. The equation for the work energy theorem is work equals delta kinetic energy. W represents the net work done on the object. Delta kinetic energy represents the change in kinetic energy of the object. The change in kinetic energy can be calculated using the formula. Delta kinetic energy equals 1/2 times mass times final velocity squared minus initial velocity squared.
So, example number 1. How much work is done in moving a 2,500 kilogram car from rest to a speed of 8.2 meters?
So the number 1 problem, there's a car and the car has a mass of 2,500 kilogram and the car moved from rest. So it means that the initial velocity is 0 because it from rest. So take note sa mga katong terms nga at rest, stationary, and stop. So it means that the initial velocity is 0. So then a speed of 8.2 meter per second. Then sa atong given na problem, ang gipangita kay work, how much work. So ang atong formula na gamiton is work equals 1/2 times mass times final velocity squared minus initial velocity squared. So this is our formula, and work equals 1/2 times mass times final velocity squared minus initial velocity squared. So ang atong initial velocity is 0 man, so this can be disregarded. Then 1/2 times 2,500 kilogram times 8.2 meter per second squared. Then the answer, if you multiply this all, then 84,050 kilogram meter squared per second squared. So joule man ang ato ang unit sa work. So joules is just the same as the kilogram meter second per meter squared per second squared. So this is the answer. 84,050 joule.
Now let's have the number 2. A constant net force of 12 Newton is applied on stationary block which has a mass of 4 kilograms in the direction of its movement until it has moved 8.3 meters. What is the approximate final velocity on the block?
So sa number 2, there is a block and that block is being pushed. So there is a constant net force applied on the block and that force is 12 Newton. A constant net force of 12 Newton is applied on stationary block. So that means that the initial velocity is 0. The block has a mass of 4.5 kilogram. So after some time, the block has moved and the displacement is 8.3 meters. So ang gipangita man sa atong problem number 2 is final velocity. Then the formula is work equals 1/2 times mass times final velocity squared minus initial velocity squared. But however, there's no work in the given, so we also know that the work is the product of force and displacement. So force times displacement equals 1/2 times mass times final velocity squared. So kaya ang ato ang initial velocity is 0 man, so disregarded rin na siya niya. Then atong i-substitute, so 12 Newton times sa displacement 8.3 meters equals 1/2. So ang ato ang mass is 4.5 kilograms. Then final velocity squared. So ang answer running 12 Newton times 8.3 meters is 99.6 joule equals ang sa 1/2 times 4.5 kilogram is 2.25 kilogram. Then copy the final velocity squared. So we can divide both sides of 2.25 kilogram and the other 2.25 kilogram. So atong i-cancel. Then ang mahabilin is ato ni siyang that will give us 99.6 divided by 2.25 kilogram. So ang answer is 44.26666. So and so on. Then ang ato ang unit is meter squared over second squared equals copy final velocity squared. So ang nahabilin is meter squared per second squared. So it must be equal to final velocity. So atong gingon sa kaganihang problem is ang joule is just the same as the Newton meter. It also just the same as the kilogram meter squared per second squared. So atong i-cancel out ang kj sa katong joule equals Newton meter equals kj meter squared over second squared. May cancel out ang kj. Then ang mahabilin kay katong meter squared per second squared. So atong i-square root sa final velocity 44.2666 and so on. Then meter squared per second squared. The answer of that is 6.653 and so on. So ang mahabili na unit is meter per second. So na siya ang final velocity.
Law of conservation of energy. Energy can neither be created nor destroyed. It can only be transformed from one form to another. Example of law of conservation of energy is when a block slides down a slope, potential energy is converted into kinetic energy. So the first example is a 0.5 kilogram ball is tossed upward with a kinetic energy of 100 joules. How high does the ball travel? Given is the mass is 0.5 kilogram, then the kinetic energy is 100 joules. So let's ang gipangita kay ang height. So mo na itong pound. So potential energy equals to kinetic energy. So ang formula sa potential energy kay mgh. So ang gipangita man kay ang height. So gi-overrun na to siya og mass and gravity. So let's so the final equation is h of kA over mass and gravity. So let's substitute. So 100 joules over 0.5 kilogram times 9.8 meters per second squared. So calculate na lang, then the answer is 20 meters. So, muna ang height. A 500 kilogram roller coaster starts from rest at the top of an 80 meters hill, assuming the track is frictionless. What is the roller coaster speed at the bottom of the hill? When the mass is 500 kilogram, the height is 800 meters. Ang gipangitan ni kay V or speed. So potential energy equals to kinetic energy. So ang potential energy formula kay mgh, then ang kinetic energy is 1/2 mv squared. So both equation cancel out the mass. So ang nabili na lang kay gh equals 1/2 v squared. So the constant will be cross-multiplied to the left side. So 2gh equals v squared dayon. Para makuha kay square root ang both equation. So ang nabili na lang final equation kay v equals square root of 2gh dayon. Substitute. So equals square root of 2 times 9.81 meters per second. Gravity times 800 meters sa height. Then, the speed equals to 39.6 meters per second.
Hello everyone, this is our last topic, power. Power is the time rate of doing work. Number one example for power is 1,224 joules of work are applied to the bike pedal while riding a bike up a hill for 18 seconds. How much power is produced?
So this is the example given. What's a work equals 1,224 joules, then time is 18 seconds. So first to do is formula power equals work over time. Then divide 1,224 joules to 18 seconds. So the answer is 68 joules over seconds watts. Given for the second example is 500 joules and time is 25 seconds. So first, you have to divide 500 joules over 25 seconds. So the answer is 20 joules over seconds watts.